Assalamualaikum warahmatullahi taala wabarakatuh. My name is Raji Syamil Hakimi bin Rajidullah. My metric number is DE210064. Okay, our group will present about project-based learning for topic fluid dynamics. Okay, for group members, okay, first is from Syarul Adli bin Zulfikar Husni. Metric number is DE21000106. Okay, next is Raji Syamil Hakimi bin Rajidullah, DE210064. Okay, next is Muhammad Aiman bin Muhammad Yasin. Number metric is DE210097. Okay, and last is Khairul Nisa binti Yusri, DE210108. Okay, go to introduction. Okay, first, the movement of fluid, particularly their interactions when two fluids come into contact with one another, is the subject of the study of fluid dynamics. The word fluid in this context might refer to either liquid or gas. The fluid are viewed as a continuum of matter, and the fact that the liquid or gas is made up of individual atoms is largely ignored. Okay, the next is the term flow often refers to the movement of liquids and gases, and it depends how fluid behave and interact with their surroundings. Okay, flow can be in turbulent. Okay, turbulent is chaotic and laminar flow, which is smoother than laminar. Okay, next is laminar. Okay, laminar are more efficient, are more effective, and cost less energy to be lost, such as drainage system or aeroplane wings. Okay, next is objective. Okay, the objective of this project are below. Okay, first is obtain a complete and latest design of POME, which is important for treatment method selection and equipment sizing for industrial. Okay, second is make a system that is safe for environment and eco-friendly. Okay, last is provide a system that use a high quality product and low cost.
Hello and Assalamualaikum. My name is Harnisa binti Yusri. My matrix number DE210108 from section 3. So for the problem statement for this project is to find a method for producing a quality and efficient system, and to build a system should be capable of moving 300 liters of foam per minute from the processing factory to the designated foam ponds using appropriate tubes or hose and motors or pumps. Next, for the filler table, for the problem format, it seems like a problem statement. Then for the filler table, the facts number 1 is to design fluid delivery system for pump or mill effluent foam. Number 2, the system can move 300 liters of foam in a minute out of the processing factory. Number 3, the foam then discharged to the designated foam ponds. Number 4, the foam can cause water pollution. So the ideas from my group, firstly, we want to use the pipe that long-lasting, wide diameter, and able to withstand heat. Number 2, we want to use the high pressure pump to make the fluid move faster. Number 3, we want to make a wide pond to be able to hold a lot of foam. Number 4, do water treatment once a week or apply water filter to avoid pollution. And then the learning issues. Number 1, what are the type of pipes that can be used to deliver the fluid? Number 2, what is the specification of the pump used? Number 3, what is the depth and width of the pond that's suitable to hold the fluid? And number 4, how much does it cost to build a water treatment building? And lastly, for the resources needed, number 1, we find the information about characteristics for types of pipe and pump appropriate through article. Number 2, we do some research on internet and books. Number 3, We asked with the lecturer about the problem solution method and calculation used in the project. And lastly, number 4, a discussion with group members.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Yasin and my message number is DE21097. For the discussion for our PBL, the idea number 1, use a pipe that is long lasting, wide in diameter and able to withstand heat. So for this idea, we use stainless steel pipe because it stand and corrosion resistant, environment friendly, low maintenance, and lastly, strain and heat proof. Number 2, use a high pressure pump to make the fluid move faster. So for this idea, we use a centrifugal pump because it corrosion resistant, low maintenance, smooth flow, energy efficiency, and proven reliability. Next, the third idea, make a wide pond to be able to hold a lot of pomade. So for the pond, we choose anaerobic pond because it unconsumed material and no biodegradable solid should be settled in the bottom sludge. Number 2, dissolve organic material. And number 3, can reduce BOD by 40 to 80%. Okay. So this is our design for the pond. Okay. Idea number 4, do water treatment or apply a water filter to avoid pollution. So for this idea, we choose to design of polishing pomade system where the raw pomade from the sludge pit in a pump into the heater via a feeder pump. Steam will be used as a heating medium to evaporate the water from the pomade. When the pomade is evaporate until the required concentration, this fraction will be pumped out as solid concentrate. The evaporate vapor then goes through a condenser with the cooling water, acting as a condensing medium and comes out as process distillated. After that, the liquid will be treated until it become a clean water at the water treatment factory.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syarul Adli bin Zulkosni. My number entry is D21006. So I will continue with calculations. We assume that the diameter of pipe D equal to 0.2 meter, radius of pipe R equal to 0.08 meter, density of fluid equal to 1020 kg per meter cube, dynamic viscosity of fluid is 0.034 Pascal. So first we calculate the flow rates Q, 300 liter over 3 over minute. So we get the 300 times 0.001 divided by 60. So we get the value of Q is 0.005 meter cube per second. Next, we calculate the value of velocity. So we get the velocity by dividing the flow rates with the area. So we get the Q over pi r squared. So 0.005 over pi times 0.08 squared. And we get the value for the velocity is 0.2487 meter per second. Next, we calculate the Reynolds number Re. So we get the Re by multiply the value of density of fluid, velocity, and the diameter of pipe divided by the dynamic viscosity of fluid. So 1020 times 0.2487 times 0.2 divided by 0.034. So we get the 1492.2, which is a laminar flow because the value of laminar flow is below 2000. So lastly, I continue with the conclusion. The study of fluid dynamics is important because we are surrounded by fluids. Fluid dynamics is believed to facilitate work in the waste disposal section of a factory. The suggested system is thought to be workable and demonstrates a respectably high overall power generating efficiency. This system is also suggested as a solution to the oil palm industry's environmental issues with waste management and pollution control. So that's all from our group, which is Group 11. Thank you.